Go. Okay. X plus y to the 0, anything to the 0 power is 1. X plus y to the first power is? Best class ever. Okay. Now let's expand these. X plus y squared. I think you just got shut down. I think you just got shut down. X plus y squared is?
X squared plus 2xy plus y squared. What?
There's a good delay on that.
I got this time. Playing with 40 grand. Oh, you want me to say it? Oh, x cubed plus 3x squared y plus 3xy squared plus y cubed. Then the next one.
Whoa, hang on.
Okay. Oh, yeah. X to the power of 4 plus 4x cubed y plus 6x squared y squared plus 4x y cubed plus y to the power of 4. He's shocked. Y cubed? What do you mean plus y cubed?
Oh, y to the 4. Okay.
Locked in this phone.
I know. Does anybody see any sort of patterns emerging here?
Talk about this before.
Yeah, the numbers are symmetrical from the biggest coefficient in the middle.
The what?
Like, oh my god, you can't see, you don't see like where.
No. We're talking about the language that you just used there.
Biggest
The
go-
babyest?
No, the biggest.
Biggest.
It sounded like babyest. Okay, say that again, Marco, and I won't laugh.
The numbers on the left and right of the biggest coefficient in the middle are the same. And if there is none, like,
I-
Pascal's Triangle.
you know what I'm trying to say. You're just like
That?
fucking at this
Say
point.
that?
Yes. Like it's 4 on both sides, and then it's 1. And then 3 and 3, 2, 1.
Okay, all right, okay, yes, Marco is correct. Does anybody see anything else?
The powers of x decrease and the powers of
You're not allowed to say anything. You look at the exponents. X to the 4, x to the 3, x to the 2, x to the 1, x to the 0. So the x is decrease in power, the y is increase in power. If you add the exponents on each one, what do you get?
4.
That number,
the degree.
the degree. Okay.
And
All right, so there is a pattern here. If we look at if we go down to the bottom here, and we look at the coefficients. So in the first one, x to the 0 is 1. Oh, come on. There we go. Coefficients are 1 and 1, 1, 2, and 1. All I'm doing here is I'm just looking at the coefficients. So we got 1, 3, 3, 1, 1, 4, 6, 4, 1. If you push that over, essentially, just kind of straighten it all out, turn it into a little triangle. Same numbers. Torsten already did this, right? This is Pascal's triangle. So how do you get, what are the numbers on the outside always?
1.
They're ones all the way down. How do you get this number here?
You add the ones that are directly above it.
Yeah, so 2 and 1 gives me,
3,
2 and 1 gives me,
3,
3 and 1 gives me,
4,
3 and 3 gives me
6,
4. What would the next row be?
1,
So it's going to be 1,
5, 10, 10, 5, 1.
there you go.
It's very stimulating.
So, if you look at this, it matches the coefficients of this when you expand these when they're just ones. Okay? So if I said expand the sorry. The polynomial x plus y to the fifth. Instead of writing x plus y times x plus y times x plus y times x plus y and doing that, and that's going to take you a page of work, we know that the first term is going to be what? What's the first term going to be? It's going to be x to the 5. If you look at all of these, the first term, because it's going to be, in this case, it's like there's 3 of these, x times x times x gives you x cubed. Right? And the last term is going to be y times y times y gives you y cubed. It's all the stuff in the middle that is weird. So, but we know now, first term is x to the 5th. The coefficients are going to be these numbers in this row. So x to the 5th, what's the next term? 5x to the 4. So then the exponent on the x goes down 1, the exponent on the y goes up 1, because they always have to add to the degree. So y. The next one is 10x cubed y squared plus 10x squared y cubed plus 5x y to the 4th plus y to the 5th. School's going crazy. Okay, so now you don't have to write it all out 5 times. That's going to be a nightmare. You can just do this. Okay? Now, this is for, if you look at all these coefficients, it's just 1. When was the last time you saw just 1 in front of all your binomials? They're not.
What? Oh no.
So, there is a trick to this.
Oh, you have to multiply the whole triangle by the number in the front. Right?
Wait, what were you trying?
Turns out,
How the heck does this happen?
I don't know.
I'm so...
0 choose 0 is 0. 1 choose 0 is 1. 1 choose 1 is 1. It lines up that you can rewrite this using combinations. Okay? The way I think of this, if you were going to use it for binomial expansion, which is what we're going to do, is if you think of n choose 0, choose the y's. This number here is choose y. This is the number of y's you're choosing, okay? And this is the degree of the polynomial. So let's do something interesting. Okay, let me just do this. So we can go down. We need some space here. We need some space. Where's space? We'll do it right here. On the next page. Page 418. So let's do, if my pen will work, 2x plus 1 to the power of, let's make it 4. Okay. So this is that's your x term. That's your y term. Okay. So, what's the first term going to be? If you're going to expand this 4 times.
16x.
Oh, you're ahead of me.
Sorry.
It's going to be, I'm going to write it out, but then you'll be able to do it slowly after. 4 choose 0. Okay? Because what's 4 choose 0? It's 1, right? It's the outside of the triangle. This term, your x term, to that power. Okay? And just for completeness, I'm going to write the other term, but you don't have to. Okay? Because the first, it's going to be the y term to the 0 power. Plus 4 choose 1. 2x to the power of 3. 1 to the power of 1. All right, because this is our x term, this is our y term. What's the next one going to be? 4 choose 2. Whoops, 2. 2x to the power of 2. 1 to the power of 2. What do these exponents always have to add to? To your degree, right? Then it's going to be 4 choose 3, 2x to the power of 1, 1 to the power of 3. And then the final one, 4 choose 4, 2x to the 0, I'll just write it for completeness, and then 1 to the power of 4. So 4 choose 0 is 1. 2 to the 4th is 16. That's 16x to the 4. 1 to the 0 is whatever. 4 choose 1 is 4. 2 cubed is 8, so it's 8x cubed. And then 1 is 1. 4 choose 2 is 6. 2x squared is 4x squared. 4 choose 3 is 4 times 2x. 4 choose 4 is 1. 2x is 0, 0. Or sorry, is 1. You did it better. I don't even know what that means.
I just looked up to see what you were doing.
Okay.
I don't know.
Why? What did you do?
I just did the x plus y equal at using terms of x and y. So x is equal to
Okay.
2x.
How's that different?
I didn't use the choose part at all.
Okay, but what if it's a higher number? You're going to have to write out Pascal's triangle to that degree, right? Well, do you understand what I'm saying, though? Right? If I said that's 10, you're going to have to write out Pascal's triangle to the 10th row to get it. But you're going to have to if you're going to do it that way. Do you know what I mean? Did you get this answer? Did you? Okay. Where did you get these numbers? From Pascal's triangle? Yeah, because you have it in front of you. Well, how else do you have those numbers? These are this 1, 4, 6, 4. Those are from Pascal's triangle, right? You have to have those numbers. Let's do another one. Let's do a big one. Because the bigger it is, the faster this is, okay? Or the more time it saves you. The more time it saves you is the better way to say it. So let's make it, we'll make it 2x. Let's do 2x minus, yeah, you want the minus because that's when it gets tricky. 2x minus 2 to the power, what power do we want? 15?
No.
Even I don't want to do 15. We'll do 7. Okay. How many terms should there be here?
Question mark.
7 question mark. if you have, well, let's look at this one. How many terms do we have if it's to the power of 4? We have 2, 3, 4, 5. You always have one more than the power, okay? So we're going to have 8
We're
terms.
gonna have 9 terms in the end.
Okay, so we go 7, choose 0. 2x to the 7th. You don't have to write the negative 2 to the 0, but I'm going to just for completeness, okay? All right, does everybody understand how I got this bit? Once you get the first one, everything is the same except this 0 goes up by 1s, and that one means this number goes up by 1, and this one goes down by 1. That's it. And then you do your calculation at the end. So 7, choose 1. Should have picked a smaller number. 1 to the 5. I don't think we're going to calculate it. We'll just write it out. No, let's go down. Ah. What is going on outside right now? Really? The wind has emotions? There we go. Okay. Yeah, that's still not going to be fun to calculate, but that is way faster than doing 2x minus 2 to the power of 7 the way you would have had to do it. Right? Which is 2x minus 2 times 2x minus 2 times 2x minus 2 times 7 times. That's going to take you like a page and a half of work, and high probability you're going to make some errors, especially if there's a negative in there. Okay? I'm not going to calculate that out because that's a nightmare.
Can our group quiz just be like?
Just one question like this?
Yeah. Yeah.
So when this was in the curriculum, I used to always have a question like this, and I'd have to make it big enough that to discourage people from doing it the long way, but not so big that it was a gong show to mark.
I guarantee you.
I would always have somebody that would do it the long way, just to prove it to me, and then they'd get like a sheet of paper, and it's like
Yeah.
it's a gong show. Okay. Should we just stop there for today? Okay, we're stopping there for today. You can if you want. I'll do it in a sec if we want to.